Hello friends, MoNaCo here, our second lecture in our organic compounds unit. We're going to talk about alkanes today. While you might see a couple other of the homologous series in here, the main focus is on alkanes. I want you to understand how to name some basic alkanes, which are hydrocarbons, using the prefix rules and the homologous series rules. We'll also name some basic branched alkanes using the formulas as a reference. So where do we start? We started yesterday with something talking about carbon, how it can make chains, rings, and long complex molecules. So we're going to start at the most basic end of things, the alkanes, the simplest of the hydrocarbons. They all have single bonds between their carbon atoms, so you'll never see a double bond. They're all carbons connected with single links in this series of hydrocarbons. But let's get into the notes, okay? Table Q is a homologous series. Homologous series is a group of related compounds in which each number differs from the other one before it by one carbon unit. As you can see here, the homologous series covers alkanes, alkenes, and alkynes. And the similarities is that they're single, double, and triple bonds. So we got double, single, double, and triple carbon-carbon bonds. And that's the main focus for this particular lecture. Remember, carbon likes to have 4 bonds all the time. Hydrogen likes to have just 1. Okay. Table P is the organic prefixes. And Table P helps us figure out the first half of a hydrocarbon's name. And Table Q helps us figure out the second half of a hydrocarbon's name. The first half of the hydrocarbon's name is, so the first half is the prefix. That's for the number of carbons. And then the second half is the suffix, and this is for which homologous series it belongs to. And so the suffix is the ane, the ene, or the eine, and this is the series that it belongs to. So the names, when we put them all together, number of carbons and the series it belongs to, we get the name of the compound. So we're going to start actually with a formula, C3H8. So we know we have 3 carbons, so we look at our table P. 3 carbons has the prefix prop. So the first part of this name is prop, or prop. And the second part is we have to look for the suffix in the series that it belongs to. So we go back to table Q, and we're going to relate the number of carbons to the number of hydrogens. So we have 3 carbons, 8 hydrogens. So 3 carbons, C3H8. We have to see which series it belongs to. The alkanes, which will end in ane, the alkenes, which will end in ene, or the alkynes, which ends in yne. So we look at the number of carbons, 3, and we look at the number of hydrogens, 8. And we see which general formula does it apply to. So C3H8. So if N is 3, then H would be 2 times 3, 6, plus 2 is 8. So this first one belongs to the alkanes, and the end of its name, the suffix here, would be ane. So we got propane, ane. Now the second one, we have a name, and we're going to relate it back to its formula. Convert the following using tables P and Q. So this time we have the name, we're going to go back to the formula. So prop, that's our prefix. Prop tells us that there's 3 carbons. So that's C3. Now yne, the yne, the yne here, tells us that it belongs to the alkynes series, which means that we take the number of carbons, which was 3, and you take the number of hydrogens. To find the number of hydrogens, you do 2 times 3 minus 2. 2 times 3 minus 2. 2 times 3 is 6, minus 2 is 4. So the formula for this particular thing must be C3H4. Now moving on to the next one, again, we have a formula. We're going to go find the name. So we look at the number of carbons, find that it's 4. So the first part is bute, and then we look at it to see which series this applies to, C4H8. So if we come back here, C4H8, well, N is 4, so 4 times 2 gets you to 8. So this one particular belongs to the alkenes, which means that it has an ENE ending. So C4, so butene. I want you to try out these 3 to show evidence that you've watched and pay attention to this portion of the video. Again, using table P and Q to find the pattern. Now, alkanes are the saturated hydrocarbons. They're used as fuels, oftentimes, propane, butane. They release energy when they're burned. They always end in ANE. They're saturated, which means hydrocarbons with all single bonds between the carbons. They have the maximum number of hydrogens in their chains. The general formula is CnH2n plus 2, where N is equal to the number of carbon atoms. So for an example of pentane, we have 5 carbons. N equals 5. Pent, that's from table P. No, Q, sorry. Either way. And then you figure out the number of hydrogens by doubling the number of carbons and adding 2 to it, so C5H12. This whole process here is just how you plug carbon in for N. So the number, so N equals the number of carbons. Remember that. It's very important. Now, straight chain alkanes, also referred to as N-alkanes or normal alkanes, they're just straight chains. General rule for naming of straight chains is you use the prefix, table P, to tell you how many carbon atoms you have, and then you add the suffix ANE. ANE because there's no double bonds. No double bonds between carbon. That's why it's ANE. Do double bonds. No double bonds. My fault. No double bonds. Both of these pictures here are butane. We do not deal with the super condensed structural formulas. We will often deal with just this type of formula. This is a structural formula because it tells you where all the atoms are in relation to each other, and you can make a model of it using our model kits. Now, branched alkanes, they're not a straight continuous chains. They've got little branches hanging off. It's like the trunk of the tree is a straight chain, but the branches of the tree are the branches, obviously. This happens in organic molecules, especially hydrocarbons. So we've got 3 examples here. We've got some pictures, different structural formulas. Some are condensed structural formulas, some are not. Some molecules may appear to be branched, but are not. For example, this one exactly right here. If we look, even though it's in the zigzag pattern, it doesn't actually have any branches. And we're talking about branches of carbon. We're not talking about branches with hydrogen on it. We're talking about branches of carbon. That is how we know if it's a branched alkane. Okay, move on a little bit here. Naming branched alkanes is pretty simple. You use the table P to figure out the number of carbons in the branch, and you add the suffix YL. So locate the longest possible carbon chain. That is very important. That is called the parent chain. Any carbons coming off this chain are the branches. Number the carbons in the parent chain so that the branches fall at the lowest possible number. Name the branches first in alphabetical order, and then you will have your named alkane. So prefix is based on the carbons that are present in the branch, and we always have the suffix YL. Parent chain is stated last in the name, so we name the chains first, and then we put the numbers of the carbons that they're in. So for this first example, we count the carbons. We got 1, 2, 3, 4, 5, 6, 7. But we want to count from the end, which puts the branch at the lowest possible number. So we got to count from the other end. 1, 2, 3, 4, 5, 6, 7. We have a branch on the second carbon, so 2, and the branch consists of 1 carbon, which is the prefix meth. Meth, YL for naming the branch, 2-methyl. So the second carbon here has a methyl group on it, and then we name the whole chain. 1, 2, 3, 4, 5, 6, 7. I think that's hept. And since there's no double bonds, it's ANE. Let's see if I was right. 2-methylheptane. Yes, sir. Yes, ma'am. I did it right. So let's try again. The second one, we find our carbon chain, the longest possible one. 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons. So that's kind of important here. On the third carbon, we have 1, 2. Fourth carbon, we have 1. And the seventh carbon, we have 1 branch. So the way this is going to work out is we're going to say 3-meth ethyl. And then we have 4,7 dimethyl nonane. See, did I get it right? 3-ethyl 4,7 dimethyl nonane. Yes. Now again, 3 ethyl group because that's 2 carbon. 4 and 7 were methyl groups because that's 1 carbon each. I said dimethyl to indicate that there were 2 methyl groups. I could have said 4,7 methyl nonane. The di is just another naming convention. Third example. Let's take this one, and this is how you're going to do. You're going to find the longest carbon chain that you got. You got 1, 2, 3, 4, 5, 6, 7, 8 carbons. And on the third carbon, we have 1 hanging off, and the fourth carbon, we have 1 hanging off. So these are the 2 branches. So we've got 3, 4, di, it's 1 carbon, so it's methyl. And then we got octane, O-C-T-A-N-E. 3, 4, dimethyl octane. When we're practicing these in our packs, they're going to be much simpler to deal with. 4, 5, and 6. Well, 6, I'll show you the answer there. That's a crazy, crazy long one. 6-ethyl. So on the 6th carbon, there's an ethyl group. That's it right here. 4, 5 dimethyl decane. Let's see, how did we do this one? We had a decane. Let's find out this. So we had, oh, I see what it is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So naming the longest carbon chain comes first. And then we have a methyl group on 4, a methyl group on 5, and an ethyl group on 6. That's what it was. So finding the longest chain first is the most important. Then you name the branches alphabetically. I want to see you do example 4 and 5. Now, you might not be getting this at this point, but that's why we have so much practice to do in our practice pack. So when you're working on the practice, make sure you have the list of the rules as to how you name the alkanes and their branches, because you're going to have to refer back and forth to that until you've got a good handle on what it actually is. We have parts of page 1, 2, and 3 in our practice pack that apply to alkanes, branched, and straight. There's no quiz yet. You'll expect it after probably your 3rd lecture. Thank you for watching. Bye-bye.